This lesson will introduce you to a brand new topic in algebra. That topic is inequalities. So far this year we've been working with equations where we say two things are actually equal to each other. Inequalities are statements that two things are different or might be different. So we're going to be using the following symbols: greater than, less than, and then two that you might be less familiar with: greater than or equal to, less than or equal to. And just to make sure that you understand how to use these symbols, let's do a quick review. We could say that 8 is greater than 5. Similarly, we could say that 5 is less than 8. Now, if I were to write 5 is greater than 5, that statement would be false because 5 isn't greater than itself. However, if I squeeze that or equal to in, 5 is greater than or equal to 5, then I get a true statement because 5 isn't greater than itself, but it is equal to itself. Okay, that was a very quick review of greater than, less than. We're now going to look at how to translate English expressions into algebraic inequalities. So suppose someone says you need to be at least 16 to drive. Well, they're making a statement about someone's age, and they're saying that you have to be greater than or equal to 16 in order to drive. 17 would be okay, 18 would be okay. In fact, 16 would be okay. So you need greater than or equal to. All right, more than $50. This is an amount of money, so I'll go ahead and use an M. What are we saying about that money? It has to be more than 50. Notice on this example, I don't include that extra line because I don't want to include $50. I only want amounts that are more than 50. Okay, the next one, no more than 5 feet tall. So we're talking about a height, and it can't be more than 5. So let's think about that. That means it has to be less than, so I'm going to put a less than in. Now, could it actually be 5? If I say no more than 5, sure, it could actually be 5, so I need to include the less than or equal to. Okay, the next one is a temperature, so I'll use a T. The temperature is less than 40. So this one is pretty direct. It's less than 40. I don't include the or equal to because I want to exclude the possibility of 40. I want a number that is actually less than 40. Okay, this last one you might be unfamiliar with. So we're looking for a number that is between 30 and 40. That means it's got to be less than 40 and greater than 30. Okay, I don't know if you've seen this notation before, but I generally put the smallest number on the left, the variable in the middle, and then the largest number on the right. You could also write it this way. 40 is greater than n, which is in turn greater than 30. Either one of these means that the number in question is bigger than 30 and smaller than 40. I just prefer writing it this way because I've already trained myself to go from least to greatest, so I like to put the smallest number on the left and the biggest number on the right, but it makes sense either way. Whenever you combine a statement with two inequality symbols, they must be pointing the same way. In other words, we never write a statement like this in algebra. I'm just making up numbers. We don't do that. We always make sure if we're going to make a chain of inequalities that they're all pointing in the same direction. Okay, so that's how you translate an English expression into an algebraic inequality. All right, the next skill I want to go through with you is graphing on a number line. So suppose I tell you to show on a number line x is greater than 5. Well, I'm going to take this number line and I thought I was going to clone it. Thought I had it on a setting to clone it. There we go. So x is greater than 5. So the first thing I need to do is, find 5 on the number line. Let's suppose this is 3. Oops. Let's suppose this is 3, 4, 5, 6, 7, 8, 9, 10, and so on. So here's 5. So I'm going to draw a dot at 5. And then since I'm asking for numbers greater than 5, the way I'm going to represent that is by shading in the number line and showing the part of the number line where the numbers are greater than 5. And since they keep going, I'm going to go ahead and shade in the arrow as well. That's a way of indicating that it doesn't stop there, it keeps going. Okay? So you might find it useful to use colored markers or colored pens to show your shading. But anyway, that's the basic idea. Now, if instead you want to do x is greater than or equal to 5, well, let's think about how that's different. In this example, I'll go ahead and put 3, 4, 5, 6, 7, 8, 9, 10, and so on. And I'm still going to start at 5, and I'm going to shade in everything greater than 5. But there's one thing I need to do differently. Because in this example it says greater than or equal to, the way I show that I'm including 5 is by filling in this dot. That's just the standard way of letting someone know that you want to include 5 in what you're showing. Okay, so notice the difference. X is greater than 5, x is greater than or equal to 5. They look very similar. Alright, if you have to do x is less than 5, well, I'm just going to do this one really fast. Here's your number line. I'm just going to put a 5 here. Since I'm not including 5, I'm putting an open dot and I'm shading in everything to the left because that's what's less than 5. If on the other hand it says x is less than or equal to 5, that means I need to fill in the dot at 5 and shade in everything to the left. That is everything less than 5. Okay, this next one. How do you show -3 less than x less than or equal to 2? Well, -4, -3, -2, -1, 0, 1, 2, 3, and so on. Here's -3. Here's 2. And I'm looking for everything in between. So I shade in all the numbers between -3 and 2. Now let's think about my endpoints, my -3 and my 2. Since -3 is less than x, then x can't be -3, and I'm going to leave that dot open. On the right hand side here it says x is less than or equal to 2, which means I want to include the 2, so I'm going to shade that dot in. To summarize, an open dot, like here at -3, that means we're not including that number. A closed dot, like the one I have at 2, means we are including that number. Okay, there is one more skill with inequalities that we'll go over in class, and that's actually solving them. It's a lot like solving equations. But for this video and for this homework, I just want you to practice translating and then graphing. So for each of these 5 statements, first write it as an inequality. You can use whatever variable you want. You can take my lead that I showed you in this video. You must be at least 18 to vote. That's a statement about age. So if you want to use an A, that's fine, but you don't have to. And then after you write it as an inequality, go ahead and draw a number line and show it on the number line. Have this ready for class next time.